So it's 8:02. Let's get started then. My name is Daniel, and welcome to the demo class for our Python+AI course. A few things to get started. I would really like it if you guys can open your cameras, since it is online classes, and then it's just looking at me, it's kind of boring. But yeah, not required. And at the same time, if you have a question, feel free to just say it at any time. But if you don't have a question, if you don't have anything to say, please keep yourself muted. It's just so that there's no echo going on while I'm speaking. All right, thank you. All right, so today is going to be a demo class for the Python+AI class. Hence, the topic that we're going to be covering is going to be, it's going to come from a part of the very first lesson in the Python+AI curriculum. And we'll take a look at what that is right now. All right. So today we're going to be starting with the first topic, Introduction to Machine Learning Basics. We're going to go over a bit of that. And then we're going to start a bit of, and also work on a bit of the projects from our decision tree lesson. So to begin, we're going to take a look at the Python+AI syllabus, as well as some of the what the curriculum is. And this is so that you get an idea of what you're going to be getting into once you sign up for this course. So the Introduction to Machine Learning Using Python course is for those who have a basic knowledge of Python programming and are curious about the magic behind artificial intelligence. It covers let me zoom in a bit, sorry. Here we go. It covers it covers machine learning key concepts, design principles, and classic algorithms from the widely used traditional algorithms to the booming technology of deep learning and neural networks. Students will be guided to solve real-world problems with what they learn and enjoy the fun of building AI projects from scratch. Basically, you're learning artificial intelligence through Python, and you're going to be doing that by working on multiple different projects. Now, another thing that's mentioned here is you do need a background in Python programming, since the projects that we're going to be working on can get pretty difficult if you don't know Python at all. Now, if you're familiar with Java and not Python, and you still want to take this class, that's fine. I would recommend either sign up for a Python class first and just get some knowledge with Python, or take our data structure class. The data structure class is in Java. All right, now let's take a look at some of the projects that the curriculum entails. In the beginning, the projects are completely.
I got onto ThinkLand, and then I found that there is this spring AI301 Python L1 Saturday, 4 o'clock to 5:30 p.m. Or is it demo AI301-1 Python+AI Friday?
Yeah, so
8 o'clock.
the project the class today is the demo class, demo AI301 class. All right. So sorry, what's your question?
I have no idea. I've never used Python before.
All right, I think that's why you're also enrolled in the Python class. Right? I think you signed up for a Python class. All right, so let's take a look at the contents. We start with decision trees, which is we're going to touch on what that is today. Then we move into, and also, yeah, can you mute yourself because there's an echo? Yeah, I think Ryan. So we start with decision trees. Then we move to k-nearest neighbors, linear regression, and then so these four projects are more traditional. And then we move into more complicated ones, including image processing, deep learning, image classification, and then basically extensions. All right. Let's see. Now, let's take a look at what we're going to be covering today. Present. Here we go. Today we are going to be covering decision trees. Now, has anyone heard of has anyone have any experience with decision trees before, or at least heard of the term decision trees, or anything you know about it before we get started? Go for it. If you know anything about it, just yell it out. You want to jump in? What is decision tree? All right. So decision tree is essentially, let's skip these. Decision tree is a flowchart-like tree structure that helps you make decision. Hence the name decision tree. It's a tree structure that helps you, or in this case, a computer, makes decision. You can think of it computer-wise. You can think of it more as like a bunch of if statements connected to each other, right? It's like if this is the case, you choose this decision. If this is not the case, you choose another decision, and then you just keep going until you make like a tree. It looks like this, right? Visually wise, a decision tree looks exactly like this. You start out from, there are a few elements in a decision tree. For instance, the nodes are going to be the circles. And then all of the nodes are going to start off from this thing called a root node. That's going to be the very top of the decision tree. It's kind of like some kind of condition. Each node is going to be some kind of a condition. And then basically from each node, there's going to be some kind of supposedly output to it, where it connects to more nodes and more nodes until it reaches to the leaf nodes. There are also branches. Branches are going to be what's connecting the different nodes. So you can think of a decision tree structure, or a simple way of remembering what a decision tree structure is basically an upside down tree, right? You start out, how do trees start out? Trees start out with their roots, right? And then it grows upwards through the branches, and then through some stages, it reaches a leaf node, it reaches the leaves, and it stops moving. That's exactly the case with a decision tree. You start out with from your root node, and then through these branches, the branches connect you to more nodes, which connects to more nodes, and keeps going until it reaches the leaf node, which is going to be at the end. Understanding the tree structure, in the beginning, it may feel pretty trivial. Like, well, what's the point of memorizing this? But later on, when we get to larger decision tree projects, in the curriculum, when we get to larger decision tree projects, it's really important to recognize what the relationships between different nodes. And then this really helps you in terms of building the tree. Right? The purpose of a decision tree then is to help you make decisions, or in this case, decide the best answer to a question. Now, we know that computers can make simple decisions if we just use if statements, right? Like, if this is true, do this, else do that. But what if it's a bit more complicated? And what if it's not as straightforward as we think it is? For instance, let's look at the question, shall we go out and play tennis? Now, you can make these questions depending on the situation. Maybe there's a really straightforward answer to it, right? What if if your parent says, no, you cannot go play tennis? Then your decision to this question is just, I won't go play tennis, right? It's straightforward. However, what if there are multiple elements in there? What if we don't have such a clear-cut answer to how we make a decision? In this case, what if we choose whether or not we want to go play tennis based on the fact that, based on the temperature or the climate outside? Let's say outside is sunny, cold, and has a weak wind. Based on these facts, should we go play tennis or should we not go play tennis? How do we make a choice? How do we make a choice? And this is where decision tree comes in. Decision tree takes on all of these different factors and helps you make a decision. All right. Now, so that's a quick introduction to decision tree. We'll come back to that really quickly. Before we move on, let's go over machine learning. What's the difference between machine learning and rule-based AI? Rule-based AI is strict, right? It's referring back to that example. If this is the case, we do that. If our parent says you cannot play tennis, you don't play tennis. If the temperature outside is sunny, we play tennis. It's straightforward. Machine learning, on the other hand, works like this. You first collect data, right? Based on your data, based on whatever happens, the computer trains or creates a model. And then they use this model to make a prediction. Whereas in rule-based AI, you can think of it as we tell the computer exactly what to do or exactly how to make decisions. Here's some of the ways you can keep track of which is which. Rule-based AI is going to be human knowledge, right? We tell the computer what to do exactly, tell what to do step by step, and it's going to be when the guideline is simple, when in such cases. Machine learning, on the other hand, is going to be the machine, the computer, is going to be building the model. The knowledge is going to be learned by the machines, and simple guidelines don't apply. Reason simple guidelines don't apply is because we use machine learning for the purpose of when the rules are complicated. Otherwise, if it's really simple, we always can just use rule-based AI. But if it's complicated, we use machine learning or AI. A good example of this is, let's say you want to train a robot to play basketball, right? Obviously, you can hand code it to tell it, okay, this is what you're going to do to shoot a basketball. It's going to be way too many steps in there. Instead, what you can do is tell the machine, hey, here are a bunch of ways you can play basketball, and let the machine figure out on their own, try to train it. That's a pretty simple example. May not work as effectively as you think it will, but machine learning. All right. Now, back to tree structures. So here's what a tree looks like. We talked about a bit of some of the important structures here, including the nodes, branches, parents and child relation, root node and leaf node. Another thing that's really important that I didn't cover is the relationship between different nodes. In this case, a parent and children. Node A is going to be node B's parent, and node B is node A's child if A and B are on the same branch, and A is one step higher in the hierarchy. Look at the example on the right-hand side. Let's just make this a quiz. So let's take a look at these two sets of nodes. Yeah, let's do this. Which node is which node's parent? Which node would you say is which node's parent? I know we have a lot more people than usual in the usual class, so jumping may be more difficult, but anyone want to participate?
I think that 4 is like the child of 2.
Exactly. All right, and a few people put in the chat too. Perfect. Node 2 is going to be node 4's parent, and the opposite wise, node 4 is going to be node 2's child.
Are we only going to do this, or are we going to get into any actual coding?
We're going to get to some coding. Let's save for the end. Actually, I'll explain. So, yeah, I'll address it at the end, all right? Because the reason we have to go through these presentations is because we can't really get to the machine learning coding part without first understanding the machine learning concepts behind it. Does that make sense? All right. So
that whole demo class is like you teaching us how to make a game.
Well, okay, so the thing with the machine learning demo class, different than the Python and Scratch demo classes, I do want to address this. The difference between machine learning and the Scratch demo class or Python demo classes is that each project in the machine learning unit is a lot bigger, right? There's a lot of materials we need to cover before we can actually get to the coding part. The coding part is the majority of the demo of the curriculum. Like 90% of it is students coding. However, you can begin coding without first understanding what this is.
Almost over.
Huh?
Is the presentation almost over?
Oh, there's a bit more. All right. Yeah, let's continue. So here's a quick quiz on what the machine learning is. The decision.
9.
10, because 0.
Exactly. It's 10 nodes. 10 nodes. All right. How many branches in this tree?
9.
9.
Perfect.
9.
9. Exactly. All right. Actually, we just did this one. Node 2. Look at this one. What are the child nodes of node 5?
7 and
7 and
8.
8.
7 and 8. Perfect. Now keep in mind, that's really good. Yeah, 9 is not going to be a child node of 5. It's only a child node if they're connected on the same branch. All right, perfect. Now, which node is a root node?
0.
0.
0, exactly. And which nodes are the leaf nodes? which nodes will be the leaf nodes? It will be let's see something. 3, 6, 8, 9. Exactly. Yeah, it wouldn't just be 6 and 9. Leaf nodes are going to be nodes that don't have any more coming out of it. So it's not the one that's on the bottom, but just any one that's like reached an end. So 3, 6, 9, and 8. All right. Yeah, and these may seem pretty trivial at first, but once we start coding, these nodes are going to understanding the relationship between different nodes are going to play a role in how you actually create the model.
I have no idea. I don't really understand this. I'm just.
All right, what's confusing you?
I don't know. I just don't really understand what nodes and everything are.
All right, so
Yeah,
nodes.
just parts of the tree are just called parts of the tree.
Sorry, what did you say? What the last part? What's the last part of the question?
Just hard to exactly understand since I've never took a Python class before.
All right. So as of right now, we're just basically covering the structure. It's though I would recommend taking a Python class first before if you do want to take this Python+AI class. You do need Python knowledge to
I have no idea what Python is.
that. So we have a Python course. I think you're enrolled in it actually, the 003 class. So start with that first. I would recommend. All right. But let's move on then. So tree structure, basically this. Nodes are going to be the circles. They're going to have values in them. Like nodes are going to be these circles, and then branches are going to be the thing that's connecting the nodes. Now, let's take a look at our example. Shall we go out and play tennis? How do we make a decision tree that can help us create decisions to
Oh,
how do we go out and
I
play tennis?
know.
Yeah, go ahead.
It's because you can look at all three categories. It's sunny, so it's possible to go out on Monday, Tuesday, Wednesday, and Thursday. But at the wind, along with sunny, Tuesday and Thursday get eliminated because it's strong wind. Sunny and Monday and Wednesday is still going, and then when you go to the next one, there's Wednesday gets eliminated because it's cold, but Monday has sunny, and then the wind is weak, and then the temperature is also warm.
So what you said there is really good, actually. So do you see how complicated it can be if we just write out these strict rules? Like if we just look at each condition and see.
Basically, I just looked at like each one to figure out sunny, 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 sunny. So these are left, and then I kept on looking at with the ones that are eliminated, I won't do it because I go Outlook first, and then see Monday, Tuesday, Wednesday, and Thursday good. So they are the only ones left, and then I look at the second one where the wind is strong, get eliminated. So it's only Monday and Wednesday, and then the next one on Wednesday it's cold, so that gets eliminated. And then sunny week, the wind when it's sunny, and then the wind is weak, and then the temperature is warm, you can do it.
Right. See, okay, so great points, right? Sometimes if you look at the temperatures and look at the wind and outlook, you may just be look at this and decide whether or not you want to do that. But just from what you said, right? There are a lot of different rules you basically set, right? If we first look at if it's sunny, then we look at how strong the wind or how weak the wind is. Then look at the temperature. If we set a clear goal, if we set these clear if statements, it may get really, really complicated. Like you just said, you mentioned all these different rules, and there are all these combinations of sunny, rain, weak, strong wind, weak wind, warm temperature, cold temperature. What is an effective system? Help us make decisions if we don't want to get too complicated with the system, right? And the answer to that is we can create a decision tree model through machine learning. Now, what you're looking at right here is going to be is what we call data. And let me explain what data is. So in the case of data, these are going to be past something that's already happened, right? So think of it as this way. Let's say like last Monday, right? This is purely hypothetical, but let's say last Monday, I thought, hey, it's sunny outside, the wind was weak, it was warm temperature, and I decided to go play tennis. Tuesday, it's still warm temperature and sunny outlook, but it was strong wind. So in any case, I felt like it, I still want to go play tennis. And hence we keep going forward. But on Thursday, when the wind was strong and it's cold temperature outside, I just didn't feel like going to play tennis. So instead, I stayed home. And then on Friday, even though it was raining, but it was pretty weak wind and the temperature was warm, hence I still decided to play tennis. All right. Now, and then et cetera, et cetera, et cetera. Now, from a human perspective, we can look at this, and then we can create a bunch of rules out of this. Or we can let a computer do it. Create a decision tree.
Oh, this is what you did if there are two upsides on a day, then you chose correct go out.
No, that's not exactly the case. I mean, if you take a look at like let's see. And I'm not sure if this is like the perfect example. And again, also, what is an upside? What is a downside, right? Let's like with weak wind, cold temperature. Sometimes what if I like cold temperature, right? Like I like cold temperature here, but I decided to go playing tennis anyways. There's no clear-cut rules here. Hence, we want to use the decision tree. All right, so a few vocabularies let's cover. Oh God, this keeps happening. We first have our features. Features are going to be descriptions, like your outlook, your wind, your temperature, and then what your basically the description of the data, or each data entry. You then have your labels. Labels are going to be outputs for each data entry. So in this case, what's your decision, right? On Monday, my decision is to go play tennis. That's labels, right? Yeah.
You spelled the word wrong. It's HOW.
Where? All right. In any case, yeah, and then the whole thing combined, your features combined with the class labels, that creates data. So let's do a quick exercise then on building a decision tree. How do you build a decision tree? So since the data set we're looking at is really small, there's only 7 entries here. We can actually build a decision tree by hand. All right. What I'm going to do is I'm going to walk through how I would build a decision tree right now. And then after this, I want you to build your own decision tree based on this data entry. Okay. Just a little quick exercise. So first, what we can do is we can first look at the outlook. Now, if you look at, remember, outlook is a feature. And the feature outlook has two values, right? The values are sunny and rain. So first look at outlook. Wait. So if you can just stay, if you're not speaking, just stay muted because there's an echo. All right, thank you. If you look at outlook, so you have sunny and rain.
I am muted.
All right, no problem.
You asked me to. For
So
what?
if you look at sunny, then if you look at the data for sunny, then all of the data sets left over that are sunny is going to be these data entries, right? Everything below is going to have rain in it. So for as of right now, we can ignore looking at the bottom 3 entries and just look at the top 4 entries because they have the value sunny. In these 4 value sunny, can we just from looking at the data entries, can we figure out a rule to play tennis or not? We cannot. And the reason is the labels are not pure. There are labels where it says we can play tennis and label that says we cannot play tennis. So we cannot make an effective decision yet. So we have to keep splitting the data. We have to keep going. Right. So after looking at sunny, then since we cannot find a good answer yet, what we get down to then is we can look at outlook. Sorry, we can look at temperature. Temperature also has 2 values. It has a value for warm and cold. Now, if we look at this box, the first box, right? And then if we look at all the values that are warm, that'll leave us with the first 2 entries. If you look at the first two entries, you'll see that by the end, at this point, we don't even need to look at how strong the wind is. No matter how strong or how weak the wind is, as long as it's sunny and it's warm, we'd play tennis. So we can basically say, if the outlook is sunny, temperature is warm.
Doesn't it not matter? Couldn't you just wear a jacket if it's cold?
For the purpose of this exercise, let's ignore these things. All right, this is like a past data entry. The point of this is we want to see some kind of pattern in the data so that we can make decisions in the future. All right. All right, let's see. So then we can look at a few more things. What if it's cold? And if it's cold, we look at the bottom two data sets here. That's not what I want to do. Here. And then we still cannot figure out the answer because there's a yes and a no. Then we just have to keep splitting the data. And then let me just click through all of it. And then as you can see, that's how you create a decision tree. Right. And then on the right-hand side, I just skip through it, but it's the same idea. You then look at the bottom three entries, you keep splitting the data, and blah, blah, blah. Right. And how do you predict the decision tree? Well, to predict the decision tree, we just follow the lines, right? So if it's sunny, so let's say we're looking at data entry where, okay, first it's sunny outside. If it's sunny outside, we go down left path. Cold, weak wind, yes, we play tennis. Right? It's pretty similar to predict what this is. So, a few more things, a few more vocabularies. You'll notice that what we just covered a bit earlier in terms of the nodes and leaf nodes come into play here. All of our non-leaf nodes, you'll notice that they're going to be our feature names, right? They're going to be outlook, wind, temperature. All of our branches are going to be our feature values, or what are the potential values for that feature. And so let's say for wind, it's going to be weak and strong. For outlook, it's going to be sunny and rain. And our leaf nodes, all of our leaf nodes are going to be our class labels. So yes, we play tennis. No, we don't play tennis. That's it. All right, so let's do this. Let's take 10 minutes, 5 minutes, maybe 10. This is the same data set. What I want you to do is on your own, let's say, I recommend paper, pencil. It's easier to draw it out. Create your own decision tree. Basically what we just created back here, right? Create your own decision tree, but don't follow the format I did. Right? In my case, the first feature I use to split my data with is outlook. I first look at outlook to split the data into two sets. Try maybe instead looking at temperature first or looking at wind first, right? Come up with your own decision trees. And then, so just create your own decision tree based on this data set right here. Let's take
I'm not in the mood of making a decision tree right now.
Well, that's the activity right now. So
Can I just pass it?
it's just drawing it out, all right? And it's a bit of thinking exercise. So 5 minutes. If you have any questions, let me know. If not, we'll regroup at 8.
Are we ever gonna get into any coding, and how long is this?
We'll get into the coding. It's a whole project that we're looking at today. The demo class is 1 hour.
How long is this gonna be?
The demo class is 1 hour, but the whole decision tree project is 4 hours long.
9 o'clock?
Yeah.
So I'm gonna sleep.
As if that's your sleeping time.
What?
All right, just work on this entry project. Trust me, it's fun. Create a decision tree.
I won't be glad if we don't do any coding.
Someone asked the question: can the root node be any of 3 features? Yes. I want you to use a different feature. It doesn't just have to be outlook. It can be wind, temperature, and yeah. It can't be the label though, right? Label is going to be the answer.
Yeah. Hmm. 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 Hmm.
Oh, and if you're done, let me know. Just like private answer me. Someone asked, are the values of the features always binary? No, it doesn't have to be. You can have more than one values. A good example, a pretty common usage of decision tree is let me think. See, the big project for this unit is a project on the given data set of people. You want to figure out if the person is going to buy a Nintendo Switch or not. Right. And then you can have different characteristics of different people. And there's going to be more than one values for the feature. In fact, even in this case, we can make the data set more complicated by having the wind to be weak, strong, moderate. Outlook can be sunny, rain, snow, storming, whatever, right? So yeah, the feature values don't always have to be binary. Good question though. Underneath the root node, would it be the two other characters or the yes or no of the root node? Underneath the root node, it depends. If after the root node, you basically after each node, you split your data set into two different subsets, right? In our case, we first look at Outlook and it had sunny and rain. So you first look at all of the data set that is sunny, and then you'll see that for all of the data entries that had the Outlook sunny, we can't immediately figure out whether or not we want to play tennis because the answer is not pure, right? There is no mix with all the yeses. So since we don't know what the answer is exactly or what the label is exactly, we have to keep splitting. Right. So yeah, under the root node, usually speaking, it will be other features. Since usually after just splitting the data set by one, you still have to split a bit more to get to an accurate result. Right. By the way, if you're done, message me. Just send a message in the chat. All right. And then I think we still need a bit more time, so we'll move on at 8:37. And then we'll get you some coding.
What coding? And how do you even get onto coding?
Today's code, I'm going to explain what we're going to be coding in just a bit. But it's going to be recursion, because recursion is a big part of creating a decision tree. Creating it. All right, one more minute, wrap it up.
What the? Okay. 1 minute. Yay.
I know this stuff may feel trivial at first, but trust me, when you get into the actual code, it's important to see how it all plays out. I'll show what the code is by the end of the course. We're not going to be able to get to it today. We only have 1 hour, and the entire project is meant to be 4 hours long. But I'll show it to everyone.
Can we even at least start coding?
Yeah, in 1 minute.
It's 8:37.
It is 8:37. Thank you. So if you haven't finished, that's fine. Feel free to finish up on your own if you want. You can take a screenshot of this. But it's demo class, so this is not going to be homework or anything. And so those of you who finished, awesome. Usually at this point in the course, I would ask if you had to share your decision trees. But at the time in the demo class, we're not going to do that. Now, so for the curriculum, in the actual course, we code in this thing called Jupyter Notebook. I think a few of you probably have heard of what that is before. If you haven't, that's perfectly fine. That's going to be our main coding environment. The reason is by using Jupyter Notebooks, you can install a few packages there, and then you can directly use templates that we send to you. More importantly, if you've used Jupyter Notebooks before, know that you can split up your code into different cells. You can run each cell at one cell at a time, and that's really helpful in terms of working with really big code. But to set that out, we actually usually dedicate some part of the time to set up your coding environment, install a few packages, set up Jupyter Notebooks, which we don't have the time for today. So for the purpose of today's demo class, I want you to pull up your own coding environment, all right? And then we're going to work on a few recursion projects. So, let's start with a brief explanation of what recursion is. I will make it since we don't have much time. Recursion is a method of solving a problem with the solutions to smaller instances of the same problem. A really good example is a Fibonacci sequence. What is Fibonacci sequence? Fibonacci sequence is a sequence where you start out with a number 0 and 1. And for each number that follows the first two, for each number that follows, the value of the numbers are going to be the sum of the previous two numbers. So the third number in the Fibonacci sequence is going to be 1, because 0 plus 1 is 1. The next one is going to be 2, since 1 plus 1 is 2. Next one is 3, since 1 plus 2 is 3. Next one is 5, so 2 plus 3 is 5, etc. Now, we can use recursion to find out the Fibonacci sequence. Like, let's say we want to find out the 25th term of the Fibonacci sequence. You can do it by hand, obviously. That's going to take a while. Why not let the computer do it? Right. And you can do, and then this is where recursion comes in. Right here is going to be how you would recursively find the Fibonacci sequence. The first, you would first define a function, right? Where the 0th term is going to equal to 0. First term is going to equal to 1. And every following term, or every nth term, is going to equal to the sum of the n-1 term and the n-2 term. There you go, just like that. And then we can see how this plays out. Let's say we want to find the 4th term of the Fibonacci sequence, right? Let's say n is 4. We want to find the 4th term. So 4th term is 4 equals 0? No. Is 4 equals 1? No. So you would find, instead, then you would find out the third Fibonacci term, the sum of the 3rd term and the 2nd term. Now, what is the 3rd term, right? Then you would go back, plug in 3 in here. Is 3 equals 0? No. 3 equals 1? No. And you would just keep going, right? And then you will find the 3rd term and the 2nd term until you get the 1st term or 0th term. You will know they're equal to 0 or equal to 1, and then you return it. And then you just kind of backtrack upwards. Here's the diagram. There you go. Here's a quick diagram for what it looks like. Let's say you want to find the 5th term. You would just find each of the following terms, which would try to find each of the following terms until you reach to our base cases. Now, three laws of recursion. You first must have a base case. So in this case, the base case is going to be our n equals 0, n equals 1.
Start coding.
The algorithm must call itself recursively. So that's going to be this part. And then finally, a recursive algorithm must change its state and move towards a base case. So as you can see, n will start as a positive number and move towards 0 and 1.
Yeah, in this thing.
All right. So coding time. On your notebook, let's work on this problem. You're climbing a staircase. It takes n steps to reach the top. Each time, you can either climb 1 or 2 steps. Tell me, how many distinct ways can you climb to the top? You could do this by hand, right? Let's say you can just write it out. But there's a really simple recursive algorithm you can use to find out how many distinct ways you can climb to the top. And the idea is, there's only 2 ways to reach the next step. Either you can do 1 step, or you can take 2 steps. All right. So see if you can. Let's spend let's say 3 minutes just thinking about how you would approach this problem. If you have an idea on how to do it, start coding. Just start coding on your. Just start coding on your.
Coding.
Yeah, we're gonna start coding now. This is coding. Here's a coding problem for you.
This doesn't seem like coding. I want to get on the actual Python to code.
Yeah, that would be how you would do it.
But I don't even have Python on.
Right. If you don't have Python, just search up online Python editor in Google, and then you'll find one. Right. So the task right now, just spend 3 minutes, see if you can think of some ways to solve this. You don't have to start coding immediately, but if you know how to do it, let's go for it. If you have an idea on how to do it, feel free to put it in the chat. I would like that.
How does this even showcase? How does it work? I
The
got
online,
into online Python. Can I share my screen to show you quickly?
yeah, sure.
I want to know, or can you go show me where I'm supposed to be?
Well, everyone has a different Python editor. Actually, this is a good idea. So if you don't have a Python editor, just do this. Control T, Command T, Command T, please. Chrome, lagging. This is awesome. Hello. Computer. This is nice. Can you guys hear me? Someone yell something out if you can hear me. Oh, I'm back. Let's go. All right. You can just search up online Python editor. There you go. First thing you see. There you go. Type something in, press run, and it will run. All right. That's it. All right. Now someone put, let me see. Let me go back to my slides. Someone put in the chat. N number of ones make one of those ones and twos, and all of the number will be twos. Yeah, I don't wrote something in the chat. Yeah, that's a good idea actually. Let me see if I can reword that a bit clearer. So the way you can approach doing this problem is you can recognize that how many ways can you climb? Let's take a look at the fifth step. How many ways can you climb to the fifth step? Well, how many ways are there to reach to the fifth step? You can either go from step 3 and then take a step with a size of 2. You can take 2 steps, right? Like a step with a size of 2 steps, up to step 5, or you can go from step 4 and take 1 step to step 5. So the number of ways you can get to step 5 it depends on how many ways you can get to step 3 and how many ways you can get to step 4. And so the number of ways you can get to step 5 is basically the sum of how many ways you can get to step 3 and how many ways you can get to step 4. Does that help? Think of that as a hint. It's really, another hint, it's really similar to the Fibonacci sequence. At least the idea. While working, another thing you want to consider, since we're doing recursion, think about what is your base case and what is your recursive relation. Think about those two things. What is your base case?
I have no idea how this works.
How the code works or how the recursion stuff works?
I have no idea how to make my own code on this thing.
Wait, let's take a look at that right now. Actually. So look at my screen. So just, oh my God. If you search up Python online Python editor, right? You see that online Python editor? And then click the first thing. There you go. This is it. You can just write stuff in here. Print
Yeah.
there.
Yeah, but how do you make photos appear and stuff? I'm not on the same thing as you.
Well, the first one. You don't want to make photos appear. That's not the goal here.
I clicked the second one.
That one works too. There you go. Run. Boom, it worked.
No, I wanna is it possible to make sprites and photos?
That would take a lot more coding skills. It's really difficult. To add in photos is really difficult. But yeah, it's doable, but we're not doing that right now. Right now it's this problem. What time? All right, so let's move a bit forward with this then. Once you see these two lines, I want you to basically finish up the code, all right? So with this recursive algorithm, you have your base case. What is your base case? The base case is going to be your first two steps. There's one way to reach to step one. You take one step. And there's two different ways you can reach step two. What are the two ways? You take one step and take one step, or you take two steps at once. Every following step is just a sum of the previous two steps. How do you reach step 5? You take the sum of how many ways you can reach step 3, how many ways you can reach step 4. There you go. So that's our recursive relationship. Now, given this, see if you can create a function called climbing stairs, in which, given the n steps, given the input n, tell me how many ways you can reach the top of the stairs using recursion. All right, so we'll do this for like there's not a lot of time left. Do like 5 minutes. All right. We'll move on. Wait, let's show this right here.
I printed what the fuck, what the fuck, what the fuck.
Hey, language, please.
What?
Let's keep it clean. What am I showing? This is what you're looking at. All right, someone asked, what would the function be in this case? Name the function, name it whatever you want. I call it climb stairs. All right. I call it climb stairs. Ryan, please. Wait, Ryan, you know this is recorded, right? So don't curse, please. All right.
What?
Don't curse. It's
Can I share my screen and you'll know what?
it's not a good habit to get into. All right. It's not. Trust me. It's not a good
My
habit.
thing says, what the fuck? What the fuck? What?
I know. I can mute. I don't want to mute though. I don't like forced muting.
And I just deleted it. You're about to see. Dummy eye. Smoosh. Bam.
2 more minutes. 2-minute warning. 2 minutos. One more minute.
What the?
All right, let's take a look at the code then. So it's just 5 lines. That's basically what you need. If you got that, great job. Right, basically, and then if you don't really understand what's going on inside recursion, perfectly fine. Recursion is, recursion, it takes some time to wrap it around your head, like what's really going on in the code. So if you don't understand this, what I really recommend is just plug in one number, let's say set n equal to 5, and just run it by your hand. Just manually take a look at it. I manually calculate it out. Once you do that, you'll see that it works out. Recursion, fun topic. At home, if you're interested in doing a few more recursion problems, there's a few quick ones that we cover in our curriculum, but I'm not going to go over today. Some of them, one of them is Tower of Hanoi. Just search this one up. It's a really popular recursion problem. There's like just online everywhere. Tower of Hanoi, that's one. Another one is predict the winner. You can probably search this one too, and it'll probably be up there as well. All right, but now this recursion problem is going to be more difficult than the usual ones. I mean, the one we just covered. This is a bit more code here, but all fun. Coding is fun. All right, so that is almost going to wrap up our decision tree demo class today. Now let me break down what the rest of the class is going to happen. All right, since again I can't really go over the whole thing today. So the goal here, the reason we go over recursion is because once you go over recursion, you'll see that the algorithm in which you created a decision tree, which is right here, involves recursion. The recursive property comes in right down here. Right. The idea is you build a tree that builds smaller subtrees and builds smaller subtrees, although you reach onto the leaf node, and it connects backwards, recursively. All right. And build a smaller tree. Right. Although connects backwards, recursively. All right. Now, so and then a few more things before we end the class. Let's go over, take a look at this is a big project that the class is going to be focused on once we go over the presentation in the curriculum. This is the by-switch project. So in the by-switch project, you're given a data set, what the data looks like, in which you have a bunch of entries of different individuals. You're given their age, if they're a student or not, what is their income level, their credit rating score, and finally the label, which is whether or not they decide to buy a Nintendo Switch. Based on this data, your goal is given some person, given their features, you want to determine whether or not someone is going to buy a Nintendo Switch or not. Here's the code. Right. I'm not going to get into it. This is the materials for the curriculum. But the step is you start creating a data set first, and then there's a thing called get majority that it's covering the presentation later on. Get subset. It's basically in the beginning when you see that or values that have the value of in our tennis example, for features that have the value sunny, you create a subset of those and you call a distance tree function on the subset, and then at the end you put them all together in a create tree function. Right. So that's the big project for this tree project. And yeah, I didn't want to go over this today because really to get that we have to go over quite a bit here, including like this stuff and get majority and whatnot. All right, last thing before we do, since it's a demo class, if you're interested in signing up for the 301 classes after the demo class, feel free to sign up using this link. It's probably messaged to all of you already, emailed, but I would still recommend saving it somewhere. Right, just use this link. And you can choose your own schedules. I think even if you don't like any of the schedules here, you can request for a schedule of your own. And yeah. So this is a link to sign up for the 301 class. I'll just put it in the chat. If you have any more questions regarding the 301 class, regarding any of the materials we covered, or regarding just anything else, feel free to ask now. Otherwise, have a great day. I will see you soon, hopefully. Bye.